All right. Good morning, class. Today I'm gonna do paper 4 again, but this time will be November 2019. Okay. Um. So let's start. Let's go through question number 1. For question number 1, I noticed that this question number 1 costs 15 marks. So technically, the 15 marks question is randomly put in the paper 4. It's either from question 1 to question 4. For question number 1, it's about extension, about spring. A student in a laboratory investigate how the length of a spring varies with different load L are added to it. Measure the length L of the spring shown in the diagram 11.1. Do not include the loops at the end of the spring in your measurement. What they mean here is the loop itself is this one. Do not include this particular small loop, okay? So all you need to do is to measure, meaning you have to take your ruler, and then measure the measurement. So the measurement here is you need to measure from, make sure you do not include the loop. It should be somewhere here, starting from this point. Make it small. Measure from this point up to this point. Okay. All right. So that will be the length L. So this one will be the length L. Sorry, it should be this L, small letter L. So that will be the L. In exam paper, when you have the paper, when you use your ruler, when I check the marking scheme, it should be around 66 millimeter or 6.6 centimeter. Record your answer in table 1. So this is your table 1. So you have to have, since the unit is in millimeter, you have to convert to millimeter. It will be 66. Okay. Now, that you will give you 1 mark. On the diagram, figure 1. Draw a ruler in a correct position for the student to measure the L in the laboratory. So back to this diagram, you have to place the ruler. So when I put the ruler here, so I have to minimize this one a little bit. Okay, the ruler must be exactly put on the bench. So the bench itself, this will be your bench. If we follow our practical exam, this will be our bench. So the ruler will be placed vertically. I don't think you have to put the clamp. All you need to do is to place, draw the ruler. Okay, so that will be your ruler. All right, now it is very important to show the red line. Sorry, it is very important to show the red line to know between which area the L will be measured. All right, so that will be the ruler. The student determine and as accurate as possible the reading of the ruler at the bottom of the spring. Mark with an X position of the student eye. Now I think in this case, I think we better mark it at 0 here. Make sure it's at the same level. And then the level I here, make sure it is horizontal. Make sure it is horizontal. That is the eye level. Make sure it's horizontal. So that will be giving, that you will give 1 mark with in X position of the student I. You need to place X, okay? Put X, position of student I. So X should be here, X. I'm sure I should just put here X, okay? They will know where, based on your diagram, they will know where is X is. Next one, complete the table. Once you have the table is complete, you will notice that step one way to improve the table of the results. Step one way to improve the table of the result. Okay, somehow this one kinda need to refer to the marking scheme. So the marking scheme here, if we, how do we want to improve the table? Oh yeah, I think we need to have more reading, I think. Which is, let me check for one. Okay, that will be question number B, part 1, no? Oh yeah, list reading in order of increasing or decreasing log. Okay, now I get it what they meant. Now you will notice that the order of this lot, you will start from 1 and then 3 and then 5 and then 2 and then 4. That is not in order. So basically, if you want to improve, make sure you have all in ascending order. So put as ascending order. Okay, all right, put as an ascending order. And then after that, we need to draw the graph on the grid 1.2. Plot the graph L against small letter L as x-axis. Start both axes from the origin 0, 0. So this is very important. You have to start from 0, 0. Okay, you cannot break the graph. So I already kind of bit start with the graph. As you can see here from the x-axis, basically you have to label. You have to label. X-axis will be L. Now please remember L. When you label here L, you need to put the unit. Okay, don't forget the unit, because the unit is very, very important. We call this one label axis up. And then here we have capital letter L, which is Newton. You put slash, and then as you can see here, we start at 0, and then here will be 0. That we mean by 0, 0. And then we put 20, 40, 60, 80, 120, and so on. And basically the graph, it's already perfectly scaled for your values, and then it should be giving you guys the full scale graph. Okay, and then for the y-axis, since it is not in order, you will notice that 1, 2, 3, 4, the maximum is 5. So we can put here 1. Now some of you will put 1, 2, 3, 4, and 5. All right, I'm done. I'm okay with it. Now please refer to your graph, refer to your table. You will notice that this point 1, it's better to put with the correct significant figure or decimal point in your graph as well. I noticed this one from your graph paper, from your exam paper. You don't follow actually the method that I told you last time. Okay, this was 5.0. Now you have a better scale, you have better representation of your graph. Next will be labeling the graph. Now the first one is 0.1 to the 66, and 66 should be here. Try my best because it's kind of a bit small. 1 and 66. Okay, now it should be somewhere here, so put a cross there. Next one will be 2 100. This one will be very easy. 200, that will be there. And then after that we have 3 130, 3 130, 130 will be, let's use a ruler. 130, that will be there. And then we have 4 163. Oh, I think I did a mistake. Okay, now I forgot about the maximum is 200. My x-axis is wrong, so I should start from let me check. 36. If this one is sorry about that, it's very important to put all the values inside the graph. Now if the n will be 200, I assume this one will be 200. The middle one will be 100. Am I okay? Now I'm correct. Okay, so this one is 50. This one will be 75. Okay, and this one will be 25. This one will be 75. This one is 125. This is 150. And then this is 175. Okay, now I think we can start again one more time. 1 is 66. Where's 66? Okay, now it's very difficult. Between 50 and 75 is 25. Oh no, so I need to take calculator. So every value you have 10, huh? So 25 divided by 0.25. Where is 66? So in the middle here, check with calculator. 50 plus 75 divided by 2. This one will be 62.5. This is 65. This can somewhere around here. Yeah, it should be here. Okay, that will be 66. That will be very difficult to check. Okay, if I do 20, 40, this one is every 25. 20, 40, 60, 80, 100. No. If I do 30, if I do 40, 50, no. Yeah, I think this is the best one. I think now it's 2 is 100. 2 is 100 will be very easy. 2 100, and then we have 3 130. Again 130. So the middle one here is take the middle part. 125 plus 150 divided by 2. This is 137.5. 37.5. Now it's 135. Just again. 130. Okay, sorry. This is 137, 135, 1325. Sure, it's here. Yeah, should be around. Should be here. Okay. Okay, now, and then 4 is 163. Okay, 163. Now this is 160, 170, am I correct? 165, 160, 165. Okay, now I get it. 160, 1625, 162.5. Okay, 2.5 should be somewhere 3, should be somewhere here. Okay, and the last one will be 5198, 198. Okay, so 200, 2.5, yeah, should be somewhere here. Okay, oh, that's kind of annoying. Now we draw the graph. I think my point is kind of weird, the first one. At the 1, 2, 3, 4, the fourth one, I can check later. Okay, that will be my graph. Let me check again. One, that is number 4. Number 4 is 163. 163. This is 160. Sorry, 115. Okay, 155. This is 160. Should be somewhere here. Now I get it. Now it's better. Oh no. Yeah, it should be here. Okay, so now I have a better straight line, and then after that, once you get the graph, I'll just wait for a while. Yeah, sorry about that. Let's continue. Okay, step 1 improvement for the table of the result. Yeah, I did put it here because it is not in order. Make sure you put it as ascending order. Next one, whether L is directly proportional to L. Yes, the answer is yes, because as L increase, L also increase. Okay, and use your graph to determine L0 of the unstretched spring. Show on your graph how you did this one. You will notice that the unstretched spring, meaning when the load is 0, when the load is 0, you will notice that when the load is 0, you will notice that this will be your value. Okay, the length of the spring will be that one. Okay, when the load is 0. So so if I want to check, this one will be 2, this one is 30, so it will be 32.5, so it should be 32.5 millimeter. Okay, L0 32.5. Using your graph, determine the extension E of the spring. Now here is kind of a bit tricky. The word here is extension. Okay, we know that from the formula, we know the formula extension is equal to final length minus original length. Okay, so if we use the formula here, will be the L minus L0. Okay, So by looking at lot 3.6, 3.6, we need to check the 3.6 here. Take a ruler. 3.5, 3.6 is here. Draw a line. Now from there, draw a line to the bottom. Okay. 3.6, it's at 150. 150, yeah, it's at 150. Yeah, should be around 150. Yeah, at 150. So the length here is, I will continue the working here. It is 150 minus 32.5. Okay, because minus with the original length, so that will be 150 minus 32.5. It will be 117.5. Okay, you will notice that the marks is kind of a bit big for 2 marks, huh? I mean for a simple mark it should be 1 mark, but here we give you 2 marks. It should be at the additional steps. From the axis, draw the sketch level sketch. We just want to sketch, very easy. L and E, they are directly proportional, so this will be the graph. Now normally the graph of L against E, the length against extension, normally they will have like this at the end. At the end you will have here, and this will be the limit of proportionality. However, in this experiment there is no limit of proportionality, there is no exceed the point, so basically it's just a straight line. Next one, a gradient of the graph figure 1.2 measured the force constant. So basically here the word force constant is actually spring constant. The greater the force constants, the harder the spring to be stretched. The second spring has the same unstretched length but a greater force constant. Using the same axis, draw a line to show how the length of this second spring changes as load are added to it. Label this as S. Now, when you draw S, it says that it has a greater spring constant. The word greater spring constant here is, if you use the formula F is equal to KE, okay, K is the spring constant, so K will give you F over E, so this will be the gradient. Okay, so meaning if it says that greater spring constant, meaning greater gradient, so meaning it is a steeper gradient. Okay, so if you want to draw a steeper gradient, basically it's very easy. We just take a ruler, make it better steeper graph. All right, so you will have that one label as S. So we finish question number 4. We move on to question number 2. Number 2 is kind of simple. Question number 2, perform an experiment to measure the density of water. You have a test tip, put it on a top pen balance. Basically they want you to answer in 3 significant figure. Will be very easy. This one will be 13.6. okay, you should know this one. It shows the new reading of the measuring cylinder. Record the value of the V2 in the measuring cylinder. By the way, you need to highlight this part. the initial value will be 65. Okay, now after you put the test tip inside, you need to measure the new volume. It is very, very important to see the level from the meniscus. So that will be the meniscus, the bottom meniscus. So here, because of 60 and 80, in between here should be 70. Okay, so 70, 70, 72, 74, 76, 70, 72, 74, 76, 78, should be 79. All right, should be 79. Do not put 79.0 because the accuracy of this measuring cylinder is by 1 centimeter cube. Next one, calculate the increase in volume reading in V9. Did I put 79? Just no. 79 and 65. So increase is 79 minus 65. So basically the answer will be 34 centimeter cube. Okay, suggest one source of experimental inaccuracy of the reading scale on the measuring cylinder. Now, source of experimental inaccuracy, basically in this source, it will be one of the possible error that can caused by normally like human. Normally they don't read from lower meniscus or the eye level. So wrong eye level. Even if you look at the marking scheme, I'm sure that what they meant here is okay, that will be the, now you can see that not reading perpendicular to the scale or at the eye level, it's not measured from the bottom of the meniscus. So that will be the answer. You just pick one answer. And theory suggests the density of water is given then by rho mass over volume. And then all you need to do is to calculate 13.6. Forgot the value. Yeah, 13.6. And then divided by 34. Unfortunately, here we don't have any unit. Now, not all the question here in paper 4, they provide all the units, but somehow this one, because it's 2 marks, I'm sure that the unit does count as 1 mark. Now, once you calculate, you should have an answer. I'm just lazy to calculate. You just check at the marking scheme. Now, the answer should be, you will notice that, where's the marking? Okay, now you will notice that here the marking scheme 0.971, and then the unit gram per centimeter cube as part of 1 mark. Don't forget the unit. Next one will be question number 3. Question number 3 will be about electricity. The student investigate the resistance of different length by 1 meter of a ruler of a wire, and then he place 10 centimeter from the NP of the wire and record the reading. So the voltmeter shows you this reading. Make sure you know how to read the voltmeter. Since this one is in the middle 0.5, basically this one every 0.1. Let's enlarge. That will be 0.1, 0.2, 0.3, 0.4, and now it is balanced, 0.5. So every one here will be, should be 0.21. So record your answer in the small table in 3.1, 0.31. Yeah, do 0 point, okay, 0.21, sorry about that, 0.21, okay, 0.21. And then after that, is there anything else? Yeah. And then after that, you have to measure, calculate the value R. R is equal to V over I. The voltage given here is 0.21 divided by 0.25, and then you should have an answer of 0.84. Okay, the student repeat the procedure for the length of 20 and 40 of the wire, and then record on the table 3.1. Look at the table. Within the limit of experimental error, suggest a relationship between I and R. Now you will notice I and R. Okay. How do I say? Let me check the marking scheme again. Oh, sorry. I thought it's I. It says that between L. So my mistake, huh? No, make sure you don't do that mistake. This is L and R. Yeah, now I do get it. So as L increase, you will notice that R also increase. As the length L increase, so R also increase, and L is directly proportional to R. Okay, L is directly proportional to R. Now, precaution. Describe one precaution that students can take to minimize the heating effect. Here I did remind you guys, every time when you do electrical experiment, when you switch it on, after you take the reading, you need to switch it off. The reason why is because of you will make the resistance or the wire to be heated up or heat up. When the when the wire is heat up or the resistance is, as the temperature increase, as the temperature increase, the resistance also increase. This will affect your results. Okay, now the answer here will be, make sure you switch off between readings, or use smaller currents voltage, or use a fan. Don't use that one. Make sure you answer with the switch off between readings. Next one, last question. The last question here is also about light. We did last time, light with the previous paper. The student investigate the refraction of light of right angle triangle glass prism. He used the ray box towards the WY of the prism. So WY will be this part. Okay. And now the ray box will be here. He placed two pins P1 and P2 incident ray marks on each position of the cross. He placed another two pins P3 and P4 imaginary ray marks each position with the cross. He removed the box, draw the outline, and remove it. Now the student ruler use ruler to trace and then label where the side X and Z and so on. Draw normal the prism to the point Z. Now class, somehow when you draw this one as normal, I don't try to imagine, take your time to imagine. Normal is 45, normal is 90 degree from the surface, okay? 90 degree. So this will be your normal. I'll draw this one. So that will be your normal. Like I said last time, you don't have to be long. That will be the normal length. And then that will give you 1 mark. Draw a ruler to draw the path of the ray until it emerges from the prism. So the next one will be, you have to draw this one. Okay. when you draw this one, draw straight to the surface, and then continue to the other side. This is what we call the total internal reflection. Now, don't forget about the arrow, which most students forget about the arrow. Describe overall effect of the prism on the direction of the ray. So basically, the ray is reverse or travel in opposite direction. Okay, so that is the question. Hey, that's weird. Question number, this is 4 marks. For question number 4, it costs 4 marks. It's kind of weird. I thought it's 555. This one is only 4. Anyway, so that is the end of this paper for year November 2019. So hopefully, if you have any question, please do text me through the WhatsApp. Okay. All right. Thanks. That's all.